Hey, grade 10s. I really want to take a look today at graphing motion. My goal for you guys is to be able to look at the graph of an object's motion and be able to tell what's happening in terms of, is the object moving at a constant velocity, is it speeding up, is it slowing down, is it going forwards or going backwards? Now there's two kinds of graphs that we commonly use to graph motion. We can use position time graphs, where we graph which position the object is at, where its distance or displacement is against time. But we can also graph velocity time graphs, where we consider how the velocity or speed of the object is changing over time. It's important that you understand both. We're going to be doing a quiz at the end of the week where you can tell me which one you believe is happening. But the most important thing before you make an answer choice is always to take a look at the vertical axis. Are we graphing position or are we graphing velocity? Let's consider a scenario where a car is driving along. In each of these pictures, we can assume, for the point of this graph, that they were taken 1 second apart. At time 0, when I first took a picture, the car is at position 0. And so at time 0, I have made a dot at position 0. 1 second later, at time 1, the car has traveled 10 meters. So 1 second later, at time 1, the car has traveled 10 meters. After 2 seconds, the car has now traveled 10, and another 10, it has traveled 20 meters. If we were to continue on, what you would notice is that we would get this straight line. On a position time graph, a nice straight line like this indicates that the car is moving at a constant velocity, a constant speed. This car is moving forward at the same speed as it goes. Each second, it travels 10 meters. So in the first second, this car has traveled 10 meters in 1 second. If I were to graph this on a velocity time graph, we would see after 1 second, the car has traveled at a speed of 10 meters per second. At time 2 seconds, it has traveled another 10 meters in the second previous. So after 2 seconds, it is still traveling at 10 meters per second. On a velocity time graph, if we see a horizontal line, what we notice is that the velocity is unchanging. Both of these graphs, the position time graph with the vertical or the diagonal line but straight, shows constant velocity, and a horizontal line shows constant velocity. Both of these graphs are showing the motion of the car. The difference is whether we're measuring how its position is changing or how its velocity is changing. Because a position time graph talks about how the position is changing over time, what we end up measuring here is the velocity of the car in terms of its slope. Slope is always measured as rise over run. If you pick any point on that line and you rise up to that line, so let's pick this point here. We could really pick anyone, but we're going to pick the one at the end. If I rise up to that point, my rise from where I started to where I hit the line is on my vertical axis. That's my position. My run talks about how far I'd have to run across horizontally to get to the same point. My run to get to the same point was to start here and run all the way across until I get to that same point. I started at position 0 and I ran all the way up to position 5. Slope is rise over run. I've risen 50 meters and I've run 5 seconds. 50 divided by 5 is 10. Meters divided by seconds is meters per second. Meters per second is a unit of velocity. On a position time graph, the slope that we can calculate tells us our velocity. In this example, we still have a position time graph, but our line is angling downwards. It's still a straight line, however. It's not curving at all, so my velocity is constant. But because my line is angling downwards, we notice that as time changes from 0 seconds to 1 to 2 to 3, my position has moved from almost 30 meters to closer to 20 meters to closer to 2 meters. As time goes on, the object is moving in the negative direction. This is still a constant velocity of 3 meters per second. I can still calculate rise over run. But because I'm moving backwards direction, I would say it had a negative velocity. Again, on any position time graph, if I have a straight line, my velocity then is a constant velocity. Where the line is straight and moving in an upward direction, my velocity is positive, it's constant, and it is moving in the forward direction. Where my line is straight but pointing downward, this tells me that my velocity is going to be constant but in the negative direction. It's moving backwards. If my velocity graph on my distance or position time graph is a horizontal straight line, it is still constant, but it's constant at speed 0. It's at the same position over each unit of time. My object is standing still. If I'm looking at my position time graph and I see a curved line, now I am no longer considering constant velocity. Curving upwards like this tells me my object is speeding up. However, if my line appears to curve in a downwards direction, this would tell me that my object is slowing down. The shape of the line that we see on our graph means something very different if our graph is graphing velocity against time. Velocity time graphs don't tell us anything about the position of the object as it's moving. It just tells me how is its speed changing over time. Is it moving at a constant speed? Is it speeding up or slowing down? Is it going forwards or backwards? Velocity time graphs often look different from the position time graphs because they often show both positive and negative values. On the graph below, the 0 line represents an object with a 0 velocity. It would be stopped. Horizontal lines show that the object is moving at a constant velocity. Sloped lines indicate that the object would be speeding up or slowing down. The line highlighted in green below shows an object whose velocity is at speed 0 or stopping, whether we're at 0 seconds, 1 second, 2 seconds, 3 seconds. The velocity has not changed. It's constant at a standstill. The purple line highlighted here shows that the velocity of the object was moving at 10 meters per second. After 1 second, it's still moving at 10 meters a second. After 2 seconds, it's still moving at 10 meters per second. The velocity again is constant at 10 meters per second. On these graphs, we're seeing objects speeding up or slowing down. The best way to determine this is to take a look at how has the velocity changed over time. In this first example, on the upper part of the graph, the object started moving at a velocity of 3 meters per second. As time continued, it eventually was moving at 9 meters per second. 9 meters per second is obviously faster than 3 meters per second. This object's speeding up. Because my line is angling upwards, we can assume it's moving in the forward direction. In this case, we see that the velocity started off at minus 3 meters per second. This means that this was his speed, but moving backwards. As time continued, however, the object ended up going at minus 9 meters per second. It was still moving backwards, but even faster than it was before. Both of these lines show speeding up. These lines in these two graphs show slowing down. At the start time, my object started at 9 meters per second, but as time progresses, it eventually slows down to 3 meters per second. It has a slower velocity. Because we are on the positive side of the line, we are slowing down in the positive direction. The object is moving forward. In the bottom part of the graph, a different object starts at minus 9 meters per second. It's moving at 9 meters per second, but in the backwards direction. As time progresses, and we are later in the timeline, eventually it slows down to a speed of minus 3 meters per second. It's still moving in the backwards direction, but at a slower speed. Both of these lines show slowing down. So when we consider velocity time graphs, we can see that horizontal lines mean that there's no change in velocity. Any graphed line that we see in red here that is on the upper side of, or the positive side of the vertical axis talks about moving in a positive direction, that we're going to have a positive velocity, we're moving forward. Lines graphed below the zero line on the negative portion of the vertical axis tell us that we are moving in the negative direction, that we are moving away from the line. To practice understanding what's happening in velocity and position time graphs and velocity and acceleration in velocity time graphs, I'm going to get you guys to practice task 5. Where we ask you to describe, I want you to consider, is the object moving forwards or backwards? And is it speeding up, slowing down, or staying at the same rate?